Hello everyone, myself Sarunan J. Bharati from Carbon Figure Academy. In this video, we are going to talk about whole life carbon scenario analysis. This is actually an open source tool which has been released just today, and it is all about plotting and forecasting the carbon footprint of building stocks, and it is especially meant for European Union and respective countries. So where it all started, I noticed one repetitive post and repetitive mentions about the term called whole life carbon scenario explorer. So I just stopped there and I got to read more about the mentions, and this is where it all led me to this particular post made by Shadwa Eisa. She is actually building LC and EPD engineer from Europe. So she just mentioned that she was working in the development of an open source tool, and the tool is finally ready to use for the public. So that tool is nothing but that whole life carbon scenario explorer. So she mentioned the source, the link for the tool, as well as a detailed write-up also. So when I just click that, it made me to reach this particular page where you can able to see Linktree. It is actually a social media kind of website where these kind of links can be shared. I just guess. So here we have two different links. One is the tool, another one is the paper. So paper in the sense it is a research article. It's completely getting introduced technically telling, right? So WLC scenario explorer, whole life carbon scenario explorer, an open source tool for exploring whole life cycle, which means whole life cycle emission scenarios of transnational building stocks, right? So if you want to know, read more about the theoretical stuff, you can read this paper. And if you just want to see and jump into the tool, here it is. So once we click there, it led us to this particular page, and this is that whole life scenario explorer, right? So it is actually a GHG emissions of European Union building stock scenarios. So it is not like entire LCA impact categories you can't get to know, but still only the GWP we can focus. You can able to see in the indicator GWP total, fossil, bio, which means biogenic, LULAC. LULAC means land use and land use change, right? So only that GHG emission based impact we can visualize. And this is actually a project. In the paper we can able to see that this work links to European Union project analysis of life cycle GHG emissions and removals of EU buildings and construction. Right. So it's a European Union supported project and relevant outcome, right? So we can able to see, funded by European Union as well. So this is the dashboard and this is the tool. The left side you can able to see scenarios, which is automatically highlighted, and we have filters options as well. So from which year you want to project. So they just made it very clear within a window between 2020 to 2050. So why 2050? European Union having a target of becoming net zero by 2050, right? So I am not aware about so specific about their intended targets, like whether they want to complete entire sector, entire scenario into net zero, or any specific sector like construction sector into net zero. I'm not sure about, but with respect to European Union and UK specifically, 2050 is being the target year, just 25 years more. So they are having that this particular window from 2020 to 2050 you can do some analysis with this particular tool, right? So you can able to see EU region, continental, Mediterranean, Nordic and Oceanic, right? And country wise you can split, some 24 or 28 countries I think in European Union. And with respect to building type, you can have a non-residential building which includes commercial, industrial, all other things, and a residential as well. So once you choose a particular residential, then you can choose subtype also. So when you do non-residential, accordingly you can choose, okay, office, hotel, restaurant, health, education, all those things. Then element class. So which particular material you want to focus, which means building element, whether energy related, which means operational energy, external openings, internal openings, completely about that, windows, glazing, all those things. Then electrical services, technical services, roof, staircase, floor, substructure. That's a good thing, substructure is there, which means the foundations. Then wall types, right? So element wise you can go. Then material wise also you can go, like which particular material you want to forecast, which is going to be in the upcoming year, like that, right? Then what else? Material class. Then stock activity, existing buildings, new buildings, refurbishments. So in green building facilitation concept, you can understand operational maintenance, O&M, new building, like BDC, building design plus construction. And refurbishment, it's almost like interior project, we can say, right? Then which particular life cycle stage you want to notice, right? So construction embodied carbon, renovation embodied carbon, use phase embodied carbon, demolition embodied carbon. Apart from that, operational carbon, which is in the use phase. Then modules. Instead of going life cycle stage, you can have a module wise lookup also, right? So this is like the filter options. So now we can able to see the scenarios. So what are the scenarios they have fed into this particular tool as of now? So since this is a open source tool, anyone can work and add features onto it. So the people who knows coding can able to make use of this, I think. But currently these are all the scenarios they have fed into the tool, which means optimistic current policy scenario, conservative current policy scenario, optimistic additional policy scenario, conservative additional policy scenario, business as usual. Then high diffusion across all member states, then custom scenario. So it is like by default that optimistic current policy scenario is being selected. So accordingly that graph is being shown. Like for non-residential, we have chosen non-residential, I think. Yes. So if we just unclick, so it will show both non-residential as well as residential. So you can, it is mentioned color legend, click to highlight, right? So you just non-residential, you can see that. And here also you can, if you just rover, you can able to see the numbers. So it is 2025. So this is the current statistics of contributions of embodied carbon, existing embodied carbon of building stocks within the EU region, because we didn't select any specific country. So we can, yes, let's check up with any specific country. It's a country code is being mentioned. I am not sure which is meant for which one. I can say F for France. Okay. So France 2025, we can able to see non-residential and residential contributes like 66 percentage. In 2025, 66 percentage residential and 37 percentage non-residential, within which the carbon footprint, which means the GHG contribution is from residential is being maximum, like 64 percentage, whereas from non-residential it is 35.84 percentage, right? So that's how you can interpret. And without changing anything, you can simply break down building type, subtype, class. So whatever you can able to make a filter here also you can put. Like here it is building type, right? So for example, let's go into element class. Yeah, so element wise they have splitted the forecasted GHG values, which means the global warming potential. So you can able to see external openings. So this is that number, external openings. Once you just click there, you can able to see how much percentage, 1.62 percentage. So internal openings, it is in the negative region. Maybe they are working it out like just a opening, not with any glazings or windows. So that's why it is being minus. Okay, right? So then we can again understand substructure. Let's take foundation. So what is the contribution? So it is going to be 11.15 percentage, out of which 10 percentage, around 11 percentage embodied carbon is being contributed by the foundations alone, right? So that's how it should be interpreted. So we can go material class also. We have a lot of types of materials. So the yellow contributes more. What is that yellow? That energy, which means operational energy, right? So apart from that, you may think, okay, steel and concrete, right? Concrete, yes, that's a thick color, concrete. What's the number? Yeah, so it is like 12.93 percentage and 12.39 percentage. What to say that the embodied carbon contribution, which means that GHG contribution 12.39 from concrete. So which holds major proportion? Obviously the concrete. Next to concrete, which one? Next to concrete, which element? Other construction materials. So they are not so specific, but still concrete is being the major one, we can understand, right? Divided by, yes. So this particular option has not yet been activated, we can able to see, so that you can understand the intensity of carbon footprint, like per grass floor area, like that, right? So now here you can also create custom scenario, and with which so this is actually a primary scenario, and at the bottom you can able to see secondary scenario, just for the comparative purpose, right? So here you can able to create a custom scenario and you can compare them. Here it is only one scenario, which means only the primary scenario, only the secondary scenario, and the third one is you can compare, right? So that's the thing. And here also we can able to see different visuals like bar graph, line graph, and the numbers also. So if you're not convinced with the thickness of the line or color stacking, if you don't understand much better, then you can directly click the table and you can understand the number, right? Completely it is being mentioned for material wise, year wise, right? So here in the left side, let us just randomly change the secondary scenario just to compare. So business as usual. So you are telling optimistic current policy scenario. If it is not being executed properly or implemented properly, this is how the change will look like. Can you able to see the left side, this particular thing? Can you able to see from the 2020, the left side, what you see is that optimistic current policy scenario. As per the document, if everybody works towards, this is how it is portrayed to get reduced eventually by the year 2050. But business as usual, if they don't follow the current policy, this is how it will look like, which means it's completely flat. There is no reduction till 2050, right? So here you can completely notice, in the business as usual case, how much metric ton, like 107, right? Which means that year 2035, 105.35 metric tons of CO2 will be generated. By 2050, you can understand 97. Still it is not zero. Whereas if you follow the current optimistic scenario, by the year 2050, it could be as low as 21.22 metric ton, right? So here in the left side we have several options. Define a custom scenario. How you can define a custom scenario, like avoid, shift, improve, right? So how much you are going to avoid with respect to the procurement of new materials or production of new materials, right? So that is the concept of avoid. So how it can be implemented practically, we can say circularity, building circularity index. So those kind of concepts can be utilized so as to measure the circularity within a given building space, right? So if it is 0.5, which means the circularity index 0.5, right? Then so this is actually, now the visual is showing custom scenario versus business as usual. Custom scenario is not yet completed, right? Then reduce space per capita. I am not reducing anything. Then shift low carbon and bio-based solutions from regular materials. Okay, I go with the factor of 1, right? Then improve. So reduce operational emissions. Obviously, I am going to install solar everywhere. So maximum I am going to do it. Increase use of improved materials. Okay, I will try. Then reduce transport and construction emissions. Okay, I will try. Right, now the custom scenario is ready, and you can able to understand the difference between our designed custom scenario and the business as usual scenario. Let's see whether it is going to be reduced or not. Yeah, it is reducing. So what is the custom scenario we made? Circularity we have provided 0.5. So okay, let's check if the circularity is increased. Yeah, the number is getting changed. Yes. So if you just click here, 2050, 19.98. Okay. If the circularity is changed back to 0.5, and if you come to 2050, yeah, 21.52. So I don't understand whether circularity has a negative impact or we are understanding it wrong. Okay, 21.52. If I put 1, What's the number comes? Okay, 19.98. Okay, that's fine. That's correct. We are doing it correct. Okay, if I make it the circularity maximum amount possible within the new building construction, so I can able to see it again. It is 19.98. So 1 is being the maximum, right? Then in case of shift, like low carbon and bio based material, if you go, and with respect to improved materials, we put only 0.5. Let's make 1 so we can understand more amount of impact. Yes, definitely it is reduced to 15.64 metric ton, right? So this is the strategy actually, because normally I could able to see a lot of online portals talking about net zero strategy, roadmap, organizational net zero achievement milestone. So fancy words they are using, and I really wonder what they will literally teach in all those courses or in that kind of workshops, because it is open to everyone. It is a qualitative thing and comes with quantitative measures, and everybody knows it. Very basic things. So if you completely switch to solar from your coal based or any other conventional source based energy, then obviously you can make lot of difference with respect to your operational carbon footprint, like by simply shifting to the solar. What other ways you can do, like it would be normally comes as a big action. So all those fancy words like roadmap for becoming net zero, strategical pathway for becoming net zero, this particular tool made it so clear and simplified, ultra simplified, I can say. These are the strategies for becoming net zero: avoid, shift, improve. First you have to focus on avoiding on raw materials, which means new material, virgin materials. So how it can be effectively measured with the help of circularity index and space per capita, right? Then in case of shifting mindset with respect to your new material, how you start preferring low carbon and bio based material over the existing and regular material options. Shift mindset. Then once you shift, try to improve. So how you can improve? Obviously you can focus on operational emission, that is everybody can able to do. Then increase use of improved materials. So get more educated, focus on the green procurement or sustainable procurement areas, push your suppliers for a better carbon footprint data, so that you can make decisions about different suppliers, right? Then transport and construction emissions, right? So because in construction, with respect to buildings, during the construction significant amount of emissions. So let us simply check indicator, right? Where is the indicator? Okay, life cycle stage. Yes. So if you simply put here the life cycle stage, you can't see the transport. So let's go with the life cycle modules. Whereas A4 is actually meant for that manufacturing plant to the construction site. That is the A4 one. Transport. And C2, I think that is also transport during the end of life stage. So C2, I think it's almost nothing. So A4 we can understand. This is the A4. Okay. So it contributes 1.07 percentage. This which means 1.07 amount of metric tons of carbon dioxide, right? So 1.07 metric ton, especially from transportation. So this particular reduced transport consumption emission can be effective here, because one is a significant number here. Yes, right now 2025, right? So that is the thing. So whenever you make change here, you can able to see the difference in the projections here. So here automatically, once you start defining your custom scenario, here it comes custom only, you can able to change, right? Automatically the comparison would jump here, right? Instead of primary, it would be custom, right? So once you don't want to do the custom, then you just unclick everything, shift, improve everything, then the thing will be, yes, like, yes, optimistic scenario, policy scenario, right? So here in the optimistic policy, so this is what is being highlighted. You can see avoid nothing, shift nothing, only they are focusing on improve. Can you able to understand? So the current policy actually focusing on reduce operational emissions to the max, increase use of improved materials to the max, and reduction of transportation to some extent. Can you able to see? Shift and avoid completely zero, because it is not happening. We are focusing on only trying to in our operational phase, we are trying to reduce the carbon footprint. That is what this particular policy scenario tells. Okay, let's click conservative scenario. We can understand same, but in case of improve, we just made it only 1, not as max, right? So that is why it's called conservative, right? Then optimistic additional policy scenario. Can you able to see the difference? So in additional policy scenario, avoid, that gets a number 0.5, shift, that gets a number 1.0, right? So this is what they are looking to make it happen. Current optimistic policy scenario plus added policy scenario has to take place to witness the change they want to see, right? So you can able to understand in optimistic current scenario, there is no contribution from shift and avoid, but in additional, you can able to understand, yes, avoid gets a number, shift gets a number, right? So I think this is a very great tool that we can able to visualize how our different activities can able to influence our final GHG emissions with respect to building stocks. And only regret is this is only meant for European Union region, and since this is first time got prepared and launched today successfully, maybe from some other part of the world, some other people with similar minds and ideas and intentions may jump in and add on their own data, and they may have different region gets added over the time. So this particular tool, whole life carbon scenario explorer, is a much needed and much required tool for every building professional, so that they can understand their design implications, choice of actions with respect to materials, from very small scale to larger scale projects. So how they are going to play a vital role in the every single year of which is going to come. Because with respect to European Union, it is only 2050. With respect to India, it is 2070, right? But still, no, we have to start, right? And this tool, I hope this tool can serve a lot in the context of building sustainability, right? So in the next video we will come again with some other interesting and a brand new tool which would help you in understanding the embodied carbon measurements and carbon footprint measurements, GHG emission measurements, so easier and understandable. Thank you.